Welcome to Tips Training and Certification online training program. Now we will start with the third module of Six Sigma Green Belt training. Third module is Introduction to Measure Phase and Basic Statistical Concepts. The second phase of DMAIC is measure phase, and the aim of this phase is to determine how the process currently performing, look for what might be causing problem in the process, what are the questions which needs to be investigated based on the potential non-conformities which we have identified and non-value added activities which we have identified before this question arises in process mapping. Create a plan based on these questions for collection of data. Ensure your data is reliable by using different tools. Update your project charter. Objective of measure phase is gathering the baseline information of the current process, which covers in detail planning and sampling of the data, understanding the whole process in detail, covering the details bottlenecks of the processes, create a detailed process map which includes flowchart as well as the CPOC diagram, know the present sigma level, summarize the data. Execution steps mainly involves analyzing the outcome of defined phase, study and map the process using process flowchart and CPOC diagram, identify the value added and non-value added activities, use cause and effect diagram, identification of independent and dependent variables which are the critical contributors to the processes, decide the data collection and sampling plan for collection of the information based on this independent variable, that is critical variables, and related formats, collect the data and categorize it. Based on data collected, calculate the present status of sigma level. Carry out the failure mode effective analysis and Pareto analysis for scrutinizing and shortlisting the causes of variations or problems for further analysis. Carry out the measurement system analysis to know is there any deviation in the measurement itself or not. The tools and techniques in measure phase used are basic statistics, that is mean, mode, median, standard deviation, etc. Six Sigma matrices, that is DPU, DPMO, Six Sigma level calculations. Use of different charts, diagrammatic tools, tables, line diagram, tree diagram, etc. Process mapping, that is lower level process mapping is process flowchart and higher level mapping is CPOC diagram. Data collection and sampling, cause and effect analysis, failure mode effective analysis, Pareto analysis and measurement system analysis. Outcome of this phase is detailed process map, detailed baseline data which is the actual data in the structured format which we require for analyzing, calculation of baseline process sigma, clear idea about current process working, problems with the process that may be related to critical to quality factor, that are the critical factors contributing to the process, identification and elimination of non-value added activities in the process using process map, direction towards further analysis of data. Now we will start with basic statistics in the measure phase so that this basic statistic will be useful during the overall project executions and Six Sigma understanding. The basic statistics includes the method to estimate the central tendency. There are three ways of calculation of central tendency. Three M's are mean, mode, median. What is mean? Mean or average is normally signified in terms of summarization of all the values plus and divided by number of values. For example, if there is the value 1, 2, 3, 4, then we have to calculate mean using addition of 1 plus 2 plus 3 plus 4 divided by number of values that are the 4, which is equal to 2.5. Second unit of measurement of central tendency is median. Median, what is it? This is a value which has equal number of values above it and below it when arranged in ascending order. For example, if there is a value 1, 2, 3, 4, 5, the middle value of these 5 values is the median, that is 3. But if there are even number of values 1, 2, 3, 4, then we will consider the central two values, that is 2 and 3. We will add this thing divided by 2, that is 2.5 will be the median. Mode. This is the value which occurs with highest frequency. It is possible to have more than one mode if there is more than one values which appears the most. For example, 1, 2, 2, 3, 2, 3, 4. Now most occurring value is 2, hence the mode value will be 2. Now there are different causes of variations to the process. During next step of measure phase, we will analyze this variation using different M's, mainly machines, material, method, measurement, mother nature, that is environment, and the people, that is your staff, operators, technicians, which are contributing the variation to the process. Next, calculations related to the measure of dispersion, that is variations, are range, standard deviation, variance, coefficient of variance. Range is maximum value minus minimum value is your range of data. Standard deviation, it is the minimum deviation which occurs in the process, which we will calculate in the next phase. Variance, that is the factor which determines the variations in the process. Same way, coefficient of variation CV is another coefficient to determine the variation or dispersion. Standard deviation is mostly useful in the Six Sigma calculations. Standard deviation is common measure of range. We have already discussed. Variance is the square of standard deviation. Coefficient of variation CV is equal to standard deviation divided by mean, that is equal to S divided by S. Now we will discuss the normal distribution of the data. How data is distributed should be known to us, so that based on this data distribution we can analyze the further process. Now this is the normal curve which you are seeing. This is the distribution of the data through the line X, that is unit of measurements. We have to plot the bar chart first, and plotting the line chart using the centers of this bar chart is formation of the normal curve. It should be bell shape, properly distributed towards the mean. Smoother the curve, better is the process. Normal distribution. If the frequency distribution, that is normal distribution of the set of values, is 68.26% of the value line within plus minus 1 sigma level and 95.46 of the value line within plus minus 2 sigma level, 99.73% of the value line within plus minus 3 sigma from the mean, then the distribution is said to be normal. Normal distribution is characterized by a bell-shaped curve, which we have already discussed. This is another way of the representation of the normal distribution curve, which we have discussed in terms of values. 68.26%, which means the maximum data is towards the mean value. 95.46% and 99.73%, which is distributed across plus and minus 3. Now we will explain this normal distribution calculation. For example, if for any data, if the average value, that is the mean value x bar, is 2.847, its process standard deviation, that is sigma value, is 0.016, then for calculating 1 sigma bar, we will use the formula x bar plus minus 1 sigma. X bar is 2.847 plus 1 multiplied by 0.016. Same way, 2.847 minus 0.016, that is your range is 2.831 to 2.863. Similarly, for 2 sigma values and 3 sigma values, we will calculate the range for which we will calculate the normal distribution curve. Example of normal distribution: our man always wants to reach the office on time. He collects the data on travel time from his house to office for last few months. He finds that the average time x bar is 25 minutes and the standard deviation 5 minutes. Based on the calculations we have discussed earlier in this slide, this is the normal distribution curve plotted for average 25 and standard deviation 5, 68%, 95% and 99.7. From these data we can analyze the things. 50% certain is leave 25 minutes before the work, 84% certain leave 30 minutes before the work, and finally that is the 6 sigma value, 99.9966% means you should leave 47.5 minutes before the work starts. Thank you.